Hello, everyone. Welcome. Thank you for joining us today for unlocking the power of unified namespace for Bracketology 4.0. We're thrilled to have you here. My name is Danny Haskell, and I'll be your host for today's session. But before we dive in, I'd like to go over a few housekeeping items. This webinar will last about 40 minutes, and we'll also include a question and answer session at the end. So feel free to drop your questions in the chat as we go along. We're also recording this session and we'll be more than happy to share the recorded session with you afterward. For the agenda, we're going to start off with a very quick introduction to Unified Namespace, and then we'll talk about how we use Unified Namespace for our Bracketology 4.0. And then we'll discuss lessons learned and discuss some best practices. We have an exciting discussion lined up today with Pedro and Thomas, who joined me on this webinar, who will be happy to share their insights of using Unified Namespace for our bracketology. So let's get started. In a moment, I'll share my screen. The Unified Namespace. So in classical OT, some folks refer to it as Industry 3.0 or the Purdue model. And essentially, you have the sensors connected to the PLC, and that data gets visualized on the HMI layer, can also get passed to the SCADA layer from the PLC. And if you want that same PLC data to be transferred to, let's say, the MES layer, there's another layer that PLC data needs to get through, and as well as the ERP system. So you have this kind of linear up and down data flow between the different layers, which is a bit inefficient. Industry 4.0, theoretically, you could have that PLC data connect directly to the ERP system. So in that scenario, you have these direct connections or conversations between the different systems. In this case, we have 5 nodes on the network. And if you were to have everyone talk to everyone, essentially you have something that looks like this going along the equation node times n-1 over 2. And in this case, it would be 10 different connection points and conversations between all the 5 nodes. And if you were to increase that to 6 nodes, then it also goes up quadratically. So in terms of maintaining this architecture, it could bode very costly if you think about, let's say you needed to replace the SCADA application. Not only are you just replacing the application, you also have to kind of reprogram those different discrete connections between all those systems. So here comes Unified Namespace, which was essentially modeled to simplify those connections with the idea of still allowing all of those nodes to connect and talk to all the other nodes on the network. And so in being able to do that, you have to have this like central repository that would essentially collect the data from the different nodes to allow for the transfer of data between all the nodes. And then here you have the H equals the number of nodes. And that's the basic idea behind what UNS can do, is to allow data to transfer from all the different layers in a seamless way. So what is Unified Namespace? Essentially, it's an architecture between, it can be enterprise systems with industrial automation systems. And 2 key components is to allow the exchange of the data, as well as structuring the data structure in a way to allow for real-time data transfer. So going along with the exchange, you kind of need this centralized repository that's scalable, open, and secure. And as far as the data structure, it has to be a semantic hierarchy so that you can easily find the data and if you can model it in industry standards. So for unified namespace, one of the things that you're going to try to do is to be vendor agnostic. And that way you can try to use any platform as long as they adhere to the following minimum technical requirements. Open architecture, you essentially need documented methodologies to get data in and out. Report by exception, so you have this pub-sub versus a polling communication. This will enhance scalability. Edge-driven, you essentially want the model to be driven by the edge, and this kind of serves two purposes. The people who have developed those particular applications typically will be the best at modeling that data. And lightweight, it won't take down your network. And then secure, essentially having those security measures in place. So talking about the broker technology in order to have this centralized repository. So as I mentioned, the data will come from the edge. So that data gets transmitted by this publishing client and can be received by one or more or multiple clients. So these clients are subscribing to the broker. And essentially you see here that no clients actually connect directly together. This is the second piece of UNS, which is you get your semantic hierarchy. And one recommended practice would be to follow the ISA 95. So you have your enterprise, site, area, and area is essentially production area, and then the line where you have the actual production that's occurring. Along with this model, we recommend that folks also kind of utilize functional namespaces along with the location-based hierarchy. For example, with line 1, you could have some PLC data, line state, speed, and temperature. And if you have a MES component, you could actually subscribe to, let's say, that line state and speed in order to calculate some of your OE metrics, and then publish it back out to your broker. Same thing with the ERP system. You can essentially publish your schedule and your work order of part number, quantity, start, and due date. And lastly, this is a project snapshot that we did for a medical device contract manufacturer, where we did a proof of concept, essentially integrating, it's actually 6 packaging lines. We're only showing 4 here for, I guess, simplicity on the screen, but they had 6 identical packaging lines that we integrated. They all had 6 compact logics PLCs with identical code. In order to utilize that MQTT broker, we actually used the Maple Systems gateway that talked Ethernet IP on one of the Ethernet channels. And then on the other Ethernet channel, we connected it to the MQTT broker. This way we could grab state in-feed counter and out-feed counter from the packaging lines for each line. And then we installed Ignition, where we grabbed that PLC data. And we also installed the Sepsoft module to calculate some of the OE calculations. And then we published that back to the broker. They also wanted some ERP data to get published. They had a system called IQMS, not MQTT ready. So we did have to do essentially a data ops type application here, where we exported a CSV file that got digested by Node-RED, which is an open source software, and that got published to the MQTT broker. I believe we also use Mosquito, which is another open source MQTT broker. Because this was a a pilot or proof of concept, we were trying to minimize costs for our customer in utilizing this. And then I guess I'd like to turn that over to Pedro and Thomas to kind of show you how we actually implemented UNS for the bracketology.
Thank you, Danny. I'm gonna share my screen real quick here. Give me a second. There we go. Yeah, so to start, I want to kind of give you a quick overview of what we set out to build here and why we chose to build a UNS for this project. So as most of you know, or even if you don't know, March Madness is a college basketball tournament, and it's one of the most exciting event sports every year. And we wanted to create a system that would allow users to participate in a bracket prediction tournament, like the ones hosted on other websites, but we wanted to do it while leveraging industrial data tools, sort of to demonstrate their capabilities and how we can use these tools to our advantage. So our goal was to pull real-time game data from ESPN, and then store user predictions and calculate scores dynamically as games progressed throughout the tournament. So to achieve this, we needed a scalable and efficient way to move data between multiple systems, process that data, and then make it available for visualization and analytics. So that's where HighByte, MQTT, and Ignition came in. So we designed a unified namespace to structure and distribute the data efficiently using HighByte. So HighByte handles data modeling and transformation. MQTT provides a lightweight and flexible communication layer. And then Ignition serves as the user interface for tracking results and for users to make their predictions. Additionally, we store historical data in the SQL for cached results. And then we also used another software called Flow software to process scores, predictions, and live user scores. So now that we kind of have a better understanding of, we're going to see how all these pieces fit together by walking through our architecture. So here we can see sort of like a high-level view of our system architecture for this project. Each component plays a crucial role in how we process and distribute the data. So let's start with the ESPN API. ESPN is our source of truth for game data, live scores, stats, game schedules, and other team information. We're pulling data from ESPN using REST API calls that are event-driven. So that means that requests need to be sent out from HighByte to the API for it to get the data. This allows us to get data only when necessary, and it makes for a more efficient system without constantly having to make, API calls, like if you were doing them on set intervals. Then we move on to HighByte, which is our central hub of information for all of this project. It fetches the data from ESPN, it structures it into our unified namespace, and then it publishes it into the MQTT broker, which in this case, we are using HighByte's integrated MQTT broker as well. So we define data models in HighByte to ensure the data is structured consistently before being sent out to all the other systems. So you can see here we're sending data from HighByte's MQTT to Ignition, to a SQL database, and to Flow. So the first one I want to focus on is on Ignition. Ignition, like I mentioned before, is going to be our main front end for our users. We developed a front end application using Perspective, the Perspective module, and Ignition subscribes to the MQTT topics published by HighByte to display live game data to users. As you can see, Ignition also interacts with the SQL database to store and retrieve each user's predicted bracket, as well as access cached API data from the broker. So now you might be wondering, if we already have data flowing through the broker, why do we need a SQL database? So this is actually one of the key improvements that we made compared to last year's bracketology setup. The data in an MQTT broker, whether in an industrial setting or in a use case like this one, is mostly designed for real-time data streaming. So data that is constantly updating as new information comes in, and data that is always most probably changing live. But however, certain types of data that we're pulling in, like team roster, game schedules, and user predictions, don't really change that often. So instead of repeatedly pulling the static data from the broker or making redundant API requests to ESPN, we cache and store that data in SQL, which makes it faster and more efficient to retrieve that data when needed. And then lastly, we have our Flow software. So Flow plays a crucial role in processing real-time game data from the broker and the user predictions that are stored in the SQL database. Its main function is to calculate each user's score based on the actual game results, as well as to determine the maximum possible points that every user could achieve if all the remaining predictions turn out to be correct at any stage of the tournament. So once Flow handles all these calculations and they're complete, it feeds the results back to the SQL database, and then Ignition can retrieve and display them in real time for the users. So now that we have a better understanding of the architecture of the project, I want to start off by walking you guys through how we have set up HighByte for this system. So here on the HighByte connections page, we define and manage all of the connections between HighByte and the various software components that are interacting with it. The first connection here is our, my bad, this is the connection screen. The first connection is the ESPN API. So this is where we're pulling our live game data. If I click into this connection, we can see the base URL that HighByte uses to communicate with the ESPN API. And if we go into our inputs, we'll see our predefined endpoints for this API. So these endpoints allow us to fetch data for our bracket systems in real time. So data like our live game data, our team information, all of that stuff. Next, we have our MQTT HighByte broker connection, which plays a key role in how the data flows across our system. This connection allows HighByte to send structured data to the broker, and it makes it accessible for both Ignition and the Flow software. And it also enables, it sort of works as a two-way communication, meaning that Ignition and Flow can send requests back to a HighByte through the broker, and that would then trigger a new API call if either Ignition or Flow needs information from the ESPN API. And then the last connection we have set up is the SQL database. Like I said before, this serves as a caching layer for more static or infrequently changing data so that we don't have to constantly be getting data from the ESPN API and getting that data from them. So now that we see how stuff is connected in HighByte, I want to take a look at how we're modeling data in HighByte. So we're using HighByte's models. Models define the structure of data, so it ensures that information coming from your different sources follows a common format. This makes it easier for systems like Ignition or SQL to consume and process the data efficiently. So for our bracketology system, we created 3 key models. We have our team, our game, and our competitor. So the team model stores details like team ID, the name, abbreviation, other team information, and it ensures consistency whenever we are referring to a team. Then we have our game model, which represents matchups against 2 teams. So it includes game ID, tournament game ID, name, maybe like the live situation of the game, which is like the last play, the probability of the home team winning or the away team winning. So all this information that we can get from the API stored and or organized in the same way. We can also see that within the game model, we have these 2, the home team and the away team, which are also a model. So if we go back here, you'll see that we have a competitor model, and inside of the game, we have 2 embedded competitors. So this means that you can make embedded models within each other, which allows you to do a lot of fun things with the way you organize your data. And just to be clear, these competitor models are just represents a team status within a specific game. So this just allows us to track each team's performance in real time. So sort of by structuring the data this way, we keep everything organized and scalable, and it's just easier to work with across all of the softwares that we're working with. And now that we understand the models, I'm going to let Thomas take over, and he can talk to you about how we use HighByte's pipelines to publish and distribute the data efficiently across all of our softwares.
Thanks, Pedro. I'm gonna take over screen share. Yeah, so like Pedro mentioned, we utilize pipelines in HighByte in order to really leverage the power of HighByte. Really starts or really is centralized with pipelines. So you'll see here we really have a minimal number of pipelines to handle all the data that's coming through the ESPN API. So actually we just have one games pipeline here that handles every game that we're receiving via the API. So if I click into this game, you'll see that we'll have two event-driven triggers to start this pipeline. So that's one thing that I think Pedro highlighted, is that instead of, you can also pull requests or pull connections, but we tried to transition to an event-driven architecture so that we weren't continuously beating down the ESPN API server in order to model a best practice for an API call. So for here, you see we have these two triggers, like I mentioned. There's either the live games trigger, which within the broker, Ignition's able to indicate that there's live games going on and continually request updates for those live games. Via the broker, we'll see that later on. And you also have unique requests that are made to the broker for game data given a specific date range, which triggers this pipeline. Moving on, you see that whether it's a live data request or a specific date range request, there's two different API connections for that, or endpoints that we hit for that. And I can go ahead and show you kind of what that data coming in looks like. If I go to the ESPN API connections and go to the live games connection, you can actually test the input out and see that this is the raw JSON response that we're getting from the ESPN API with all of your, they call it competitions in the API response with your game data and things like that. So if I go back here, that's actually how the data is structured at this point. And I use this script to just extract the events data from this package, which is all the different games that are returned from the API. And through this breakup component, I'm able to actually just break up all of the games into separate objects. So you see these numbers here indicate how many times this component or object has run. So after I break up the games here from 913, you jump to 28.6K individual games that have been modeled via this component. So this is a really powerful component here where I'm able to actually configure my model. So take the game model and map all of the data from the API response to the objects that I want it to, where I want the data properties for the games to be modeled under. So once I have the games modeled like I'd like them to, I can set up some metadata, which just helps with mapping each of the games to topics within the namespace. And then depending on whether I want to, or whether it's a tournament game or just a regular season game, we publish data for those games in a different topic structure. So, but similar kind of path here where we're flattening the properties, so it's just one topic for each game property, and then breaking up all those properties into individual I guess, topics to publish to. And then this is where we're able to actually use that MQTT broker connection and create the topic that we're publishing to via the metadata that I've already set up earlier in the pipeline. And so we can go ahead and run through what that looks like. First off, I'll go ahead and pull up this MQTT Explorer software. So this allows me to actually connect to the broker. If you look here, we set up this separate topic under request, and I can actually, just pretend like I'm a new client, never, looked at this broker before. If I go ahead and copy this URL and just follow this URL, this is actually hosted on the Ignition server, and it gives me sort of like a help document so that if I'm a new client and I never looked at how this data in this broker is structured, I can look at some document like this within the broker, and anyone can actually know how to publish requests to the broker. So you see here, if there's a topic request all teams, I get all of the teams. So I can go ahead and do that here. Essentially, request all teams, and then just set that to true. Then HighByte's actually receiving that connection, or is connected to this topic and receiving that request, and now it's publishing all Division I teams information in that same way it's modeled. And you can actually see that pipeline was triggered here, and it's handling all of those team requests. Same thing if I do another request, but this time for individual scores, I can set a request here, and just following that document, it's a start and end date. Say maybe last year's tournament. It's roughly around these dates. If I go ahead and send this request to request_scores and publish this to the broker, now HighByte is monitoring that topic, and that triggers the pipeline that I was showing you, the games pipeline. And it publishes all of that data to the broker under the tournament's namespace. So you have the men's basketball championship tournament for last year. You have all of the regions. You have the rounds for each game, and then you have the individual games within that round. All the information there, like Pedro was mentioning, you have the status properties. You have and information about the teams, like their score, if they were the winner. All of that is published, and it's structured in a very readable, user-friendly way. If I need to pull data from the broker, I'm able to easily identify where that's going to be in the broker and kind of build applications around that. Another cool feature of pipelines is you may notice this kind of branch over here. So once I established how I wanted to publish data to the broker, I could actually use this same pipeline to, like Pedro mentioned, record game data in the SQL database. So all I had to do was I had my games modeled at this point and the metadata established for each game. And it's simply just making a branching out a connection to actually insert that data to SQL. So essentially setting up, getting this game tournament ID, which is another property that we're using to map tournament games on the back end, and then mapping the data, how it's modeled per game, to columns in the SQL table, and then just running this, it's called an upsert right. So essentially either it's going to insert new data or update existing rows in the SQL table. And all I have to do is pass this game ID, and it knows to update the properties of that game as it's retrieved. And there's additional components that you can use to filter out if there's already a game that does exist in SQL that maybe you don't want to worry about updating, or only updating changed properties, things like that, that we could definitely explore, but this was sufficient for our use case. So that's HighByte. Let me go ahead and show you a little bit about Ignition and what's going on there. So I show you what the broker looked like in the Explorer client, but you can also see I have the Ignition Designer open here, and you have through the MQTT engine module, you have all of your topics in the broker populating as Ignition tags. So if I want to go back, you see it's structured the same way. And the cool thing about this is now that they're Ignition tags, I can really leverage some of the features in Ignition specifically related around tags. So for instance, I can use this tag report tool and drag that over, and I can actually browse the namespace because they're all essentially just viewed as tags in Ignition. So if I just want to look at maybe all tags underneath this tournaments topic, I can search that, and it gives me any, all the tag values in that tag path. Or I can use maybe a wildcard to just get the winners of games, and I can search that, and now it gives me the winner. And I can even add, say, like if I want to add just a value of 1, indicating that I want to know who actually won the game, I can do that, and it shows me, okay, this is the winner of this, the home team won this game. So it's really powerful tool just to be able to browse the broker through Ignition tags. You can build things around that. So one thing that we built is we built a gateway event script that browses the game, the broker at a set interval, and checks to see if there's live games that exist, and it'll actually update this request for live game data. And if I simulate what that looks like by writing this to true, you'll see that now I have live game data populated in the broker. So it's essentially just game data from today and yesterday, so that I can essentially minimize, instead of requesting games for all the tournaments, even if they've been completed for over a week, I can minimize the load I'm putting on HighByte to process through all of the games and just request the current, like the current day's games, so that we're getting that live data, live scores. So that's what it looks like in Ignition. I'm going to also show off Flow and just demonstrate what we have in Flow. So Flow, like Pedro mentioned, we are using that to process user bracket predictions and calculate the user scores based on what they predicted to be the winner of each game to be and what the actual winner of the game was. So that's something that we haven't been able to develop yet because we don't have the data for it. But I still want to just show you how easy it is to also leverage data within the broker in Flow. So if I have my data source here, you see I have a connection to the MQTT broker as well as the SQL server. And if I start browsing in the namespace here, I'm able to see all the same data that I was seeing 2024 tournaments, men's basketball championships. So it's all structured in a common way so that anyone can can subscribe to that topic and utilize that data to provide different solutions, whether that's calculating user scores or like Ignition is doing, showing a front end for actually making predictions and seeing those live scores. So that's just some of the functionality that that we have right now in Flow, and that is kind of the power behind the UNS, is being able to have a common topic structure and a common way that the data is structured in the broker, so that any tool or client can come along and really leverage that data for whatever purposes there may be. So with that, I think I'm going to turn it back over to Danny.
Excellent. Nice job, Pedro and Thomas. Appreciate it. I guess questions for you guys. Any lessons learned, challenges, and even recommendations on how to do a project like this?
Yeah, I think one thing that we encountered specifically with this project is we were trying to one of the challenges was we were trying to map data to games that weren't yet existing, because you think about a tournament, games aren't scheduled or determined until previous rounds of games have been completed to set those teams. And so we had to really get creative, and part of that was trying to build a back end to actually map undetermined games or unscheduled games to user bracket predictions. And so just trying to, maximize the user readability in the brokers, so that, we can easily see what games are and have kind of like that modeled game data consistent throughout the broker, but also keep it functional enough to where we're able to map user predictions for games that aren't scheduled to the actual outcomes of games once they are completed. So trying to manage the dynamic nature of how the broker may change, and I think in a real world application, having some sort of ISA 95 topic structure, or being able to kind of maintain some sort of standard like that would really minimize the headache with that.
Great, thanks.
That's sort of like building up on what Thomas said, is we had to dynamically know or dynamically set up our data, and or dynamic set up a way to get our data. And I think one of the best practices to overcome that is ensuring that the data is just structured and defined properly across all systems before you start developing on them. So for this, we had to carefully plan how the data would be formatted in both the broker and in the database, and then determine what would be the most efficient way to move data between those systems. So sort of by like predefining a clear data model up front before starting any development on each one of the clients, you just avoid a bunch of unnecessary rework in the future. And it's just ensures that all of the components that are interpreting and processing the data can do it without any additional transformations on the side of the client. It keeps the data consistent between all the systems, and it just makes it more scalable in the end, because it allows you to be more to expand a system without actually having to break any of the existing workflows you have. So this year, with the current architecture that we've built, it is way easier to then use the same data structures that we have for any upcoming years. So yeah, having that scalability in mind is also one of the best practices I think I recommend for streamlining development and just improving a long-term system's reliability.
Excellent. Any other advice on, I guess, how to, start out with a project?
Yeah, I mean, I think, when you look at the system like this, maybe it seems overwhelming or, looking at a full manufacturing facility and all of the devices on the plant floor and things like that, it may seem a little bit overwhelming to like where would I start? And I think the best practice and the best place to start is just to start small. Find a use case, whether that's just one device, one edge device, or one production line, and start streamlining, pulling out data from those devices into the broker so that you can just see how useful it can be for end users to have all of that data organized in a broker so that they can leverage it to provide solutions and insights and analyze the data to get some sort of measurable, or run OAE analysis, anything that you can use the data for. So I think just starting small, starting with one use case and seeing just how impactful that use case can be for your business is really just the best place to start, and then just expanding from there.
Yeah, and seeing your demo of the HighByte configuration, it seemed relatively small in terms of number of configuration. Do you have any comments about that, and why was that the case?
Yeah, I guess it's just basically because the pipeline feature is so great inside HighByte. It allows you to, like Thomas said, have one pipeline that would reach different locations. So as you saw, the pipeline would branch out into the MQTT broker side, and then after the data has been configured the way that we wanted it and structured in the way we want it would either go to HighByte and go to, or either be written and cached in the SQL database. And yeah, the pipelines just make it so easy to move and structure the data between the systems. And as you saw, you don't need to really write any complex scripts for it. You can see that instead of being structured text, it was, I think they call them stage blocks in HighByte. So those are just, they also provide like a visual way to map how the data is being processed and routed, which is, at least for me, is really helpful. And it just simplifies just pulling in the raw data, cleaning it, and sending it to whatever destination it is, all within one pipeline itself. So yeah, I guess that's pretty much why.
Nice. I guess we can open up to questions. Are there any questions?
There's none in the chat.
All right, if there's no questions, I guess that concludes our webinar. So thanks for everybody who joined, and have a wonderful day.
We do have John typing,
Oh,
John
okay.
Harrington typing. Oh, okay. Thank you, John. Also, I'm gonna share in the link on the chat the link for you guys if you want to register for Bracketology this year, so you can participate if you haven't already, and make your predictions for March Madness.
Oh, somebody's asking, did you make a UI? Is that what it says? I don't know if you guys wanted to show that at all.
Did you make any UI? Yes. So we're using the perspective module in Ignition, where users will be able to select each game per bracket. We could show off last year's games if you guys want to see that, but that's where you'll be able to select each user is going to have their own individual bracket, and you're going to select from each team in each region which team you think is going to win. And then after selection Sunday, whenever I think it's the Wednesday after selection Sunday, you can no longer make any more predictions and your bracket is closed off. And then based on the predictions you made, you can see them compared to the live game results, and you can also monitor and see the statuses of all the live games, like Thomas was saying, on our UI. And then you'll also be able to see what the current standings in for the tournament. So if you've made more predictions and guessed correctly than anybody else, then you'll be at the top, and then you'll do less points if else.
John asked, can we share the HighByte project file? Yes, we can definitely do that, John.
Let me actually share the.
I don't know if you guys see the other question. How easy would it be to your REST client connection on HighByte using different authorization methods such as OAuth 2.0? Is it easy to set up token URLs and all that? I'm not sure that we have done that yet. So I'm not sure that we'd be able to answer that at this point. Have you guys used that yet?
Yeah, it's definitely a feature within HighByte. So I can go. You look at our configuration for the ESPN API. There's an authentication type dropdown. So for ESPN API, there isn't any authentication required. But you can have basic authentication or passive bearer token, or use OAuth 2 authentication, and then you just have to set up, the authentication URL, your username and password. Looks like right now the only grant type is client credentials, but you can set your scope or access for OAuth 2. So there's definitely some configurability for setting up credentials for an API, REST API. It's just not something that we needed for ESPN. And someone was asking about the UI. I was going to just show a sneak peek to the UI. Yeah, John, that's a good point. If you have further questions about HighByte, I know their team's great at answering questions, and they're helping us a lot with this project as well, this year and last year. But for a UI standpoint, this is kind of a sneak peek to where we're at for this year, and a lot of this was kind of pulled from last year. But as you can see, there's the ability to kind of come in here and select your bracket predictions, and all of it's very responsive, and you have your team name, the seating and everything all set up here, and then you also have a live results page, so you can see the score. And this would still a work in progress, but this will show the live scores for anyone. So there's a lot of just configurability in English and perspective to make your UI really look clean, and also handle any sort of requirements for your front-end applications. So there's a little sneak peek for you.
Great. I think that answers all the questions. Thank you very much for all of those folks who have attended. Special thanks to Pedro and Thomas for helping me out today. Great job. All right.